Hello everyone, I'm Shivali Gupta.
I'm Mawang.
I'm Reese.
I'm Alex.
Our research paper is on the different ways to describe regular languages by using finite automata and the changing algorithm implementation. On the right hand side, you can see how our program is going to work. In this program, we take a finite automaton quintuple as input from a text file. The input is an NFA. The program converts it to a DFA, and then it determines whether the string will get accepted by this new DFA or not. We convert why do we take this DFA? It's because the NFA, though it's easier to design, but it is difficult to track because the movement may be in several states.
Here is the text file. The first line is the number of states. The second line is made of some integers. The first is the number of input symbols, and the following are input symbols. The third line is the start state. 0 means Q0. The fourth line is the number of transition lines. And the following lines, except the last line, are the transitions. The last line is made of the number of final states and the final states. The right-hand side is the equivalent NFA from the input file. This is the source cited.
And then here's our code. First off, the main function calls a display function which introduces the program and tells the necessary format for the input file. The quintuple to arrays function converts the NFA input into arrays, and then the NFA to DFA function obviously converts the NFA to a DFA. Print DFA will print the DFA into another text file, and then check DFA will check if a specific string is accepted or rejected by the new DFA. And then I'm going to talk about our NFA to DFA function. First, the number of states of the DFA is set to the number of states in the NFA, as well as the number of final states. And the initial state for the DFA is set to the initial state of the NFA. Then every final state in the NFA is also a final state in the DFA. And then each valid transition in the NFA transition table becomes a transition in the DFA transition table, excluding lambda functions transitions. To take care of lambda transitions, we have these nested loops, which if any transition is a valid lambda transition in the NFA, it is converted to a valid DFA transition. And then any transition in the DFA which does not have a valid transition goes to the trap state, and then the trap state is implemented. The total number of states in the DFA is incremented by 1, and each transition for every input symbol in that trap state just goes back to the trap state.
So now I'm gonna explain about the checking the DFA part. Yeah, this function is first have to type any string to check the string is working correctly at the as a DFA. And then this function is automatically checked each index is arrive at the final state. This is our compiled images. First of all, we're gonna insert in any input file names, nfa.txt, and then automatically automatically pop up any output files on the document, on the folder, and then if we insert any strings, it's gonna show that this string is accepted or not accepted. And then if you're gonna insert only once, it's gonna be not accepted. And then this is our output file for this code. Yeah, thank you.